Everybody, thanks for joining us today. We're glad to have you all here. Today we're going to be presenting cyber surveillance, tracking new malware threats. Next. Before we get started, let's go through some quick housekeeping. We'll be sending out a recording of today's webinar shortly after we wrap up. This way you can catch up on any parts you missed or revisit key moments at your convenience. Feel free to ask questions or share your thoughts at any point during our session. There's a question box in your viewer console, so please don't hesitate to use it. We're here to have an open discussion and answer any questions you might have. Also, if you're keen on learning more about threat hunting and threat intelligence, please make sure to explore the resource panel in your viewer console. We're looking forward to a great session, so let's dive in. I'm Kyle Thompson, your host today for the session, joining you from Southern California. I specialize in channel partnerships and alliances over at HYAS with a solid grounding in cybersecurity and network engineering. We also have Adam Lopez, who is also from HYAS. He's a director of solutions engineering, has a master's degree in cybersecurity from the University of San Diego, and is a powerhouse in showcasing innovative security solutions for enterprise organizations. We also have David Brunsdon, our expert in threat intelligence and security engineering, who brings a unique perspective from the operational technology sector to our cybersecurity strategies. I'm thrilled to have them both here to share their expertise and insights. Now let's go over our agenda for today. So first, we're going to kick things off with a quick introduction to the malware families. Then we'll get straight to the lab, where we're going to detonate a live malware for everybody to view. And then we'll go over some threat intelligence best practices. And then we'll go through investigating and defending against malware and end it off with a recap. So I'm excited to guide you through today's session. So let's get started with one of our main speakers today, David Brunsdon.
Thanks for that lovely introduction, Kyle. Let's take this away. Before we begin talking about individual malware families, I want to talk about what the heck we're doing at HYAS. So when it comes to malware, we have a non-stop feed of malware coming into us. And what we do is we detonate that malware. That malware, when we detonate it, it's a matter of isolation and monitoring. So all of this information that we get from our detonated malware goes into our data lake, and it's used to power our applications and provide the latest verdicts and so forth on domains and IPs, et cetera. So what is a detonation? Well, as I said, it's isolated. So it is typically done on a VM or on a bare metal server that has no connection to our existing network infrastructure. Typically done with VMs. And so what happens is we launch a new VM for each piece of malware, and we launch that malware, the act of detonating it, and then we track all of the telemetry that comes off of it. So that includes log data, where it communicates to, where that malware reaches out to, any DNS resolutions that it attempts. Whoever it's reaching out to, that's typically at C2. It could also be learning a little bit about its environment as well there. We also monitor everything that it does on the computer. So what files does it drop? What processes does it create? Does it create services or scheduled tasks? So forth. We monitor all of that. We also take the information, map it to MITRE, and this information is also, a lot of this information is also available in our malware feed. We have a daily malware feed that's free. So another aspect that we deal with when dealing with sandboxing or detonations is sandbox evasion. Sandbox evasion is very real. It's something that is put in most malware these days. So malware tries to determine if it's being analyzed. And if so, it doesn't act like malware. There's all sorts of ways malware can be evading sandbox. One super common way would just be timing. If we imagine that these virtual machines, they boot up, they execute the malware, they monitor for a minute or 5, and then they shut down. Well, if that malware doesn't do anything for 5 minutes, if it waits 10, 15, 20 minutes before doing anything interesting, before it decrypts its payload and activates it or whatever, then that can make it harder to detect. There's all sorts of other techniques used by malware to avoid detection in sandboxing. It can reach out to the internet, make sure that there is internet access, make sure that find out where it's been deployed. What's its external IP address? Where is that located? Is it in the cloud? Is it in the destination country of the actual attack? These are important things that the malware can do to determine. So it's become a bit of a game of cat and mouse, I would say. Anyways, I wanted to talk about 5 malware pieces that we're seeing a fair amount of today in our detonations. And I've sorted them into kind of, well, a little bit, we'll start with URLs. And this one is more like what happens when after initial access. That's why I put it first. It's also one of our most commonly seen pieces of malware. So URLs is a Trojan. It's not necessarily a remote access Trojan. You don't see the screen like a RDP session or anything like that. And it was originally made to target card game players, in particular poker, from what I can tell. So imagine you're a poker player, you've been hacked. It's going to take screenshots of your screen. It's going to monitor the keys you hit on your keyboard. And of course, now it's used for more than just poker. So it's initial access, get it on there first. Once you've gained initial access to the system, you might put URLs on there because it's capable of downloading additional malware, which is really where the big threats come in. So it can lead to stealer malware. It can lead to ransomware. And it's been around a long time. Anyways, we're seeing a lot of this one out there. Sality is another big one. And again, this is often used after initial access. So how is initial access occurring? Well, I don't really know. It happens in a lot of ways. It happens through phishing. We can implant these malware into an Excel document or an executable. We can trick people into downloading it from in a fake application, a malicious application served up by a Google ad. We could exploit a vulnerability on the server and place it there ourselves. Or we could do some credential stuffing, gain access to a computer and put it there ourselves. Sality has been recently used by Russians against Ukraine. And it's polymorphic, which is a unique feature. The purpose of polymorphic payloads is that they generate a different hash each time they're created, each payload that's created. And so polymorphic payloads are excellent at avoiding signature-based detection, which is really one of the detection methods that does the most work. Sality has been around for a long time. It's a well-known malware family. And one thing that's really neat about it is that it uses peer-to-peer for communications and exfiltration. So when I hear a peer-to-peer, I think of technology like torrents, BitTorrent or whatever. And it operates in a similar fashion. And that can make it hard to track in its own way. StealC is a relatively new one on the scene that we've started seeing more and more of. Now, this is not necessarily the initial access type of malware that you would put there for persistence. This is stealer malware. It targets your browser data. It targets crypto wallets and exfiltrates all of whatever it can find to the C2 server using HTTP. It's pretty sneaky. It's written in C, and it uses standard Windows API for its functions. So it's not bringing in any new stuff. It enhances its stealth by downloading and using legitimate Windows DLL. So it operates with a lot of, let's call it living off the land tech. SteelC is typically purchased on Russian crime forums. Let's take a look at some process tree generated by our detonation regarding SteelC. There's a lot of technical characters here. There's long strings of meaningless letters and numbers. Those are just complicated file names. What I wanted to talk about was down the middle here, towards the lower bottom half, actually, where it launches command.exe to run a command. I'm going to do something similar. Take a look at what it's doing. So let me just bring up command prompt. Let's take a look at what this malware is doing. It's got a interesting command in it that's executed. On its core, it's just doing a ping to 2.2.2.2. So the malware itself is causing the computer to reach out to an IP address, and it's a unique IP address in that it's a reserved address. There's nothing ever at 2.2.2.2. It's I don't know what we call it, a null IP address. We can expand a little more on what it's doing though. So it's doing a ping 2.2.2.2, and then it's got a couple switches afterwards. And we'll take a look at this. So what it does is it pings a single time. That's what the N1 means. So it reduces it to a single ping instead of 4 pings. And it adds a timer. So that W3000, that's 3000 milliseconds. It's like a wait of 3000 milliseconds. So it was interesting to me that this malware pings out to 2.2.2.2. Let's continue with the command here and just look at what else it does. So it takes the output and it sends it to null. And what that does is it makes it so we don't see the output. Okay, so it hides it. And then it adds another command afterwards. So it's going to delete, and I don't really have a file name .exe. Oh, del file name .exe. So what this is going to do is it's going to ping that IP address once, and then it's going to have a 3-second delay in that process, and then it's going to delete that file. So rather than just deleting that file, what we have is an interesting way of creating a 3-second delay. So it's hiding its tracks by deleting this file. It's hiding its tracks by deleting the malware. But it's doing it by pinging out to 2.2.2.2. And I thought that was really interesting. Yes, it does test to see if there's a way out, if there's internet access, I guess. I'm not sure if it's really doing that. But most importantly, I think it's doing a 3-second delay. And maybe this is unique behavior that's worth investigating. If, for example, a device, a computer on your network is pinging out to 2.2.2.2. I don't know how often legitimate applications might do this. So it might be an interesting way to determine that there could be an infected machine. All right. Lockbit is a really big one in the news these days. They say about 25 to 33% of all ransomware is Lockbit ransomware. Sometimes we hear that Lockbit's done for, that it's been taken out. Then we hear that it's back. Then it's gone. Then it's back. Well, we are seeing it. It's not number one. It's not in the top 5 malware that we're seeing, but we are seeing it these days. Lockbit is a bit unique because it's a ransomware as a service. It's a product that between 100 and 200 different ransomware operators called affiliates, they pay Lockbit, or they have an agreement with Lockbit to use their ransomware, to deploy their ransomware, and Lockbit gets a cut of all the ransom that's pulled off. One thing I've heard about Lockbit that makes it popular is that the ransomware operators get paid first, as opposed to having to pay the full amount to Lockbit and then getting a cut given back to them. It has its own separate exfiltration module known as SteelBit. And Lockbit is also famous for operating with, the ransomware operators famous for operating with a triple extortion method. And that is to say, pay me or your data won't get, we've encrypted your data, so you got to pay for that. We've exfiltrated your data, so you got to pay for that or we're going to leak it. And there's a DDoS attack happening on your infrastructure right now, and that's not going to stop until you pay. So it's a triple extortion, very typical with Lockbit. One additional challenge with Lockbit is because there's 100 to 200 different affiliates, it's really hard to lock down any particular technique because they can all operate, they can all attack their own sectors, they can attack their own countries as they wish. When we examine SteelC malware, we can see, when we examine Lockbit malware, we can see the ransomware message that victims would be faced with. This is real typical for what I'm used to seeing in ransomware. Just standard warnings: don't mess with any of your own files. They like to use Tor. Visit us with Tor. Reach out to us. Let us know we've been hacked. Here's the information about your system, and then you get to talk to the ransomware operators. Taking a look further into the process tree of Lockbit, we see some pretty nasty stuff in here, which is the kind of stuff that is a dead giveaway that this is a ransomware attack, or a ransomware attack is ongoing. So we could see cmd.exe execute right near the top, second from the top row there. And then there's this big command. There's actually several commands all together. I'm not going to be running these on my own computer. I'm just going to talk briefly about what's going on here. Windows naturally keeps backups on the computer, and we refer to them as shadows or shadow copies. So what this command is doing is it's running vssadmin delete shadows all. Hey, if you're going to run ransomware on somebody, you're going to want to make sure that they have no backups that they can restore. So this is a direct attack on their backups. There's a secondary attack that happens next, another attempt to delete any backups. So that's a WMIC, shadow copy, delete. So 2 separate commands to delete shadow copies. Then there's some additional commands specifically related to affecting the Windows boot. So it sets it so it's going to boot on error, like it'll skip past any errors and just boot into Windows, and it's going to disable any kind of recovery. And I think that's another attempt to delete shadow files. Anyways, it's all stuff to prevent. the operator, the user, the victim from restoring their backups. And now I'd like to talk about async rat. That's another one we're seeing. We see it, I think, primarily because it's open source. It's readily available to anybody on GitHub. And that's how I'm going to switch over now. Just be a moment here. Sorry about that. That should be good. I hope you can see it now. Great. So on the right, I just have a link to the GitHub page for async rat. Again, it's popular because it's open source. And I have just recently compiled a copy of it. I used Visual Studio 2019. I found that was the one that worked for me. And I should mention that I had to turn off on my attacker computer and on my victim computer, I had to turn off some Windows security. Windows Up to Date, it knows about async rat and it detects it and it shuts it off. And as it should, to really infect someone with async rat, you need to be more tricky than what I'm being. You need to use a dropper, a loader, some process hollowing, some kind of technique to get around EDR, to get around Microsoft Defender, etc. All right, need 2 copies. Let's get started with port 6606. So his simple interface, this is what the operator would work from. And what we do initially is we create a payload. So this is where we would see all of our connected victims, and we'd be able to control them individually or together as a botnet. So we need a file. We'll use the builder, and we're going to make a file to infect the user. Yes, that is my IP address here. All right, that sounds good. But in fact, I'm going to use pastebin for putting my C2 address. Instead of putting the C2 address directly into the malware, I'm going to create a new paste, and I'm going to link to that paste. Now, putting the C2 information into the malware, it works, but it also gives that information is you can find it in the malware. If I put it into pastebin, I can edit it if I need to move my C2 server without having to redeploy new malware. I can delete the information from pastebin. So I kind of like it. What I'm going to do is I'm just going to put in the IP address 4.242.17.140, and then that port number 6606. Those are not periods. Super, that looks better. Let's create a new paste. All right, let's take a look at it raw. There we go. That's my address. So when I go to this address, what happens is it just simply responds with the address of my C2. So I'll put that in there like that. And what that's going to do is it's going to put this pastebin location into malware. I don't really think I need to change any more of the settings. I could put my own. Let's see, I could put my own little icon on there. Desktop. Save copy to the desktop. Great. So now I also have a victim computer, which I'm going to infect. Let's transfer it over. So there's lots of ways to transfer files. I'm going to do the way I tend to do it. So if I use Python, I can create an HTTP server. Oh, I just need to do it out of the correct folder. There we go. So this will create a server on port 8080. And, oh, embarrassing, I need my IP address. No, we're connecting. 10.1.0.7. This is just on the same LAN, so I'm going to move it over. There we go. Now let's grab my victim and let's go get that file. Hmm. 8080. Get that port right. Not 8081. There we go. Okay, so now I can just download this file. Save it right onto the desktop. Windows is mad. Like I said, Windows is not happy about this. There we go. Let's run this file. Let's see how we did. Hey, super. All right. So we got a victim here. We got a fish on the line, right? Now, I've got all sorts of things I can do. I can monitor them all sorts of ways. I can run a keylogger. I can escalate my access. I can open up a command prompt. I can use all of my victims in a denial of service attack. All sorts of nice things to do. In my testing, the first time I did this, the remote desktop worked. And then in the second time I did this, the remote desktop didn't work. So we're 1-1. Let's see what happens. Yeah, that's what it was doing. All right, so the remote desktop feature hasn't been working great in my testing. Let's try the keylogger. So let's go back to my other computer here. Let's go to gmail.com. LarryPage@gmail.com. Try logging in. Oh, it didn't work. I guess I didn't guess the password. Let's take a look over at the keylogger. Yeah, so we could see, like, with the keylogger running, it could show how I went to gmail.com and tried to log in with the password 1234. This is a super easy way to steal all sorts of credentials and stuff, right? So there's all sorts of other tools available in async rat. I'm not going through them all today. You know, when you hack somebody, don't forget to set their wallpaper. Anyways, I'm going to carry on now. I think we're all done with this demonstration. Let's move things over to Adam. Adam, are you there?
Great. Yes, can you hear me okay, David?
Yeah, yeah. Let me just make sure. Do I need to stop sharing anything or are we okay?
Uh, I think you should be okay.
Great.
Let me see if I can make sure my camera is up here and we'll get started. All right. So thanks for that, David. It's always awesome to kind of walk through a live, a live demonstration of what the malware actually looks like on a machine, and kind of get some of those details around some of those processes and things that you're able to utilize within the actual malware itself. We're going to pivot into some kind of intelligence best practices, especially just around malware itself, and kind of go through a couple of things. I think first off, and David mentioned a little bit around signature-based detection, which we all know has been around for quite a while. It's often our first line of defense against malware itself. And interestingly enough, it's still highly utilized today, just because a lot of its effectiveness, but also, it's kind of the ability to identify known malicious files or pieces of malware with not a lot of heavy resource constraints on systems itself, or from the database side of the resources it takes to utilize signature-based detection. But as we know, oftentimes we saw, as in Salady, which David reviewed in the beginning of the presentation, a lot of new malware, and even in the rise of AI generated malware, signature detections really aren't going to provide you with a holistic ability to identify, detect, and also investigate malware. So again, some of that limitation relies on, or is its reliance on, regular updates to signature databases, which again is going to be kind of ineffective against some of the newer techniques that we see and have been seeing for years in terms of the way malware operates. Although, again, it is one of the underlying linchpins of malware detection, so it should still be part of your overhaul comprehensive security kind of program or suite, not only from a detection perspective, but from a malware intelligence and analysis perspective of understanding what different types of malwares out there are using from a signature-based approach. So moving into kind of the heuristic-based detections, right? As we start to see an advancement in the polymorphic type of malware, even the AI-generated malware, heuristics being more of a broad term, but really centering around advancements in behavioral, right, analytics, advancements in machine learning, and then even into the AI range, being able to kind of analyze those behaviors and characteristics of unknown threats is really where heuristic shines. And being able to kind of identify the kind of previously unknown malware based off those patterns and behaviors is really where heuristics comes into play. From a advancement in technology and malware perspective, I think the heuristics-based detections, specifically around those patterns and behaviors, is where we're going to see a lot of advancement. So utilizing different forms of machine learning and AI that allows us to understand those patterns and behaviors further and better and more effectively is where heuristics can really come into play. But it's one of the challenges, again, around different types of detections, but in this case, heuristics is really the higher false positive rate. So in order to remain effective with kind of minimal impact on system resources, you really have to make sure that those models or those heuristics are tuned. And so from a reverse engineering perspective of malware detonation, trying to understand how that malware operates, making sure you're tuning those specific models or heuristics is key. When we talk about implementation of heuristics, again, besides the kind of the tuning of those heuristics, and we look at the malware that may be generating whether it's weekly, monthly. As David mentioned, we see a number of different malware families consistently across our malware detonations on a daily basis, on a monthly basis. You really should use your own kind of organizational threat and risk matrix, vertical, geographic location, third-party vendors that you work with. All of those types of things should really come into play when you are tuning those heuristics and looking for specific types of behaviors within malware itself. That can be key in just being more effective and efficient in your own environments, in your own specific or tailored verticals and areas of business. So we're going to move into a little bit about safeguarding against certain types of malware. In terms of remote administrative tools, right, we're seeing a lot of continued use to try and legitimize malicious behaviors. And so, one of the main initial kind of key strategies is to implement controls and monitoring over the use of remote administrative tools within a network, whether that be from blocking unauthorized tools such as TeamViewer or AnyDesk, some remote access tools of those nature, or by conducting kind of regular scans across the environment. That will definitely help in mitigating against some of those types of threats associated with different malware families. As you might have remembered earlier in the presentation, David mentioned that a lot of times, the initial access may be through phishing or through some other means. But once there's access to the environment, the use of legitimate tools then sometimes validates, or makes it a lot harder for security controls to then detect those types of behaviors. Again, this can not only be helpful from a security operations perspective, but from the threat intelligence side, looking for different types of remote admin tools that are used in these types of malware by looking at detonations, by reverse engineering that piece of malware and understanding what might be used, can be then useful for detection of anything that might look out of the norm. So with that, establishing those playbooks that rely on rapid response for if those are detected in your environment can be another great use of safeguarding against those specific tools itself. So I wanted to jump into next kind of a way to investigate or defend against those malware specifically within an organization. And one of those is a fundamental layer of protective DNS. This is something that HYAS is well versed in and offers as part of its solution set. But really, fundamentally, if you think about the way DNS operates, it's a key component of the internet and communication within the internet, and setting up command and control or any type of remote communication over DNS is often present in a lot of different types of malware. So one of the main elements of being able to use that telemetry from a investigative standpoint is understanding or having domain knowledge and analytics around DNS infrastructure, whether that mean the domains that are being set up to be used for command and control or any of the infrastructure that might be tied to it, can help to mitigate risks associated with those domain resolutions. So not only does this help with signature-based detections, obviously, if you think about list management or policies that say, hey, if these conditions are true or if these characteristics are met, then I want to be alerted or initiate some type of block. But it can also help with understanding and detecting and being proactive against, 0 days or some of those agnostic types of threats that may not be signature-based. And what I mean by that is having that domain knowledge and those connections between, the name servers, the IP addresses, the domains associated with malware and C2 can then lead you or give you some level of confidence or a risk score that a domain or some type of infrastructure that's related or a resource related to that infrastructure is then likely going to be used in a malicious way. If you have knowledge of, let's say, all the C2s from Salady and what those characteristics look like from the infrastructure side, you have a lot more, there's a lot more ability to drive confidence levels in what the other resources might be related to. Not only that, but protective DNS in general is a fairly low resource intensive solution to not only deploy and implement, but also to manage and integrate. It is a fairly cost effective way to gain a lot of information out of your network telemetry from the DNS perspective, but also provides you that choke point in a proactive way to block a lot of the malware that we've been talking about today. And next, I want to talk a little bit about kind of harnessing threat actor infrastructure for defense. So we talked about that in the previous slide when I mentioned protective DNS. But when you think about what threat actor infrastructure is really made up of and how it is used, again, it can consist of anything like C2 servers, phishing domains, right? Email servers, exploit kits, botnets, just like David kind of created that mock, or the initiation of those machines that are now communicating back and being able to have those remote access. VPNs, proxy servers, right? So it's the interconnectivity and the relationships between all of these different resources on the internet, or these different IOCs and inflection points of what may be utilized within a piece of malware. And as you can see on the right in terms of those use cases, not only does knowledge of that threat actor infrastructure help you to proactively block, but it can also help you tailor your defense strategies, but also initiate very tailored threat hunting. So being able to not only understand where threat actors were by having knowledge of that threat infrastructure, but knowing now where they are today and also being able to predict where they're going to move can help you to be more effective in proactively using that threat intelligence, whether it's from the malware perspective, like we've been talking about today, or just from the threat perspective in general, based off of a lot of the infrastructure data that you see on the left-hand side. It can really enhance your overall security strategy, and ability to predict and also uncover where threat actors are utilizing, what they're utilizing, and where they might be moving to next. So with that, I'm going to pass it over to Kyle to go through a couple of final thoughts with us and wrap things up with today's webinar.
Perfect. Thanks, Adam. I want to thank David Brunsdon and Adam Lopez for doing the presentation today. So as we wrap things up, let's quickly go over what we learned together today. We've explored the latest movements in the malware world and looked at some of the major malware families that are making waves as of today. I hope you found a live demonstration of the detonation as enlightening as I did. It's not every day you get to see malware in action, safely, of course. This demo really shows what we're up against and how these malicious programs operate. We've also covered some critical strategies for investigating malware incidents and the best practices to help protect your systems. So thank you, everybody, for joining today. I hope you're walking away with some valuable insights and strategies that you can apply in your own environments. Don't forget to check out our additional resources and feel free to drop us a line if you have any more questions. We hope to see everybody on our next webcast.